This video is about radians versus degrees. Degrees aren't the only way of measuring an angle. Degrees had a lot of input by the Babylonian system, which had a base of 60, and you might be wondering why there's 360 degrees in a circle. Okay, my understanding is to do with the Babylonians. They had a base 60, so they had 60 individual digits, or not digits, but 60 individual characters, and that's all they had in their number system, whereas we have 10 digits. It's a base 10 system, and we just repeat the digits. Okay, so 0 to 9, and then on 10 we repeat 1 and 0, and so on. So basically 360 is a multiple of 60, and that's true for things like angles and time. Says 60 minutes in an hour. Okay, so a bit of history there. It's a rough bit of history. So it's okay, but there's a more logical unit, and a unit called radians, which also measures angle, and it's actually more convenient and it's used more often. Okay, it's used more often for anything beyond basic maths, when we're especially when we're talking about trigonometry. So degrees are used, but radians are used more often. And what we need to do is remember that the circumference of a circle is the distance around the outside of the circle, and it's 2 times pi times r. And basically the idea of a radian comes from that. So let's have a look. If we have a circle, this green one over here, and we have a radius which we draw from there to there. There's a radius, and if we draw another radius which comes up from the first radius and starts to move up, once we get to the point here where the second radius arm has moved away from the first, or rotated away from the first radius arm, such that this arc out here, also becomes the same length of the radii, the angle that makes in there is called 1 radian. Okay, so that's what 1 radian is. It's when the arc becomes equal to whatever the radius is of the circle, and if we do one radius arm stays steady and the other one rotates around, we create 1 radian when the arc length on the outside also equals r. So once we go past an angle bigger than this one here, we get more than 1 radian. So that's 1 radian there. If we go further, we'll get more than 1 radian. Now, because that we know that the circumference of a circle is 2 pi r, if we go right around 1 full revolution, we will get 2 pi radians in a full circle. So 2 pi radians is the same as 360 degrees. A lot of people base all of their work when they're converting between radians and degrees on this one here. 180 degrees is pi radians, okay? Because it's just halving both quantities up there. That's very important, so make sure you take a note of that. And basically we can look at all values in between. So if we had 360 degrees, we go around 2 pi, so it's 2 pi times the radius, or if we have 1 radian here, it'll be 2 pi times a radian, which is 2 pi radians, 360 degrees if we go right around the circle. And as we said, half of that is 1 pi radian, which is 180 degrees, and we can look at all the values in between. What if we went 90 degrees? Well, we'd have the second radius arm pointing up there. We would have traced that, and that would be half of pi, or pi on 2 radians, and that would be equal to 90 degrees. Radians can exist as decimals as well, but when you see the fraction of pi, you know you're talking radians. But as I said, sometimes it does exist as a decimal, as we may see in the future. So these conversions are worth noting, and here is an optional symbol for radians. It's not really required, because if you wrote 360 degrees equals 2 pi, it's understood that this is in radians. So the R is optional. The other thing you could do, you could just write the word radians there. So we've seen the first three just a second ago, but if we halve the 90, we've got to halve the half, so we've got a quarter of a radian. 60 degrees is a third of a radian, or pi on 3 radians. 60 degrees is, 1/3 of pi radians, which is pi over 3. And 30 degrees is pi on 6. Alright, because it's 180 divided by 6. So basically, remember, as always, you must be in the correct calculator mode. Now that we'll be working with both degrees and radians, very important you check your calculator or the software you're using to make sure it's in the mode you want it in, whether it be degrees or radians. So here we go. Here we see two equations that are basically equivalent. So they're just examples, and 4 cos 225 degrees x, that should actually have a degree symbol. It's gone away. Let me put it back. There we go. So 4 cos 225 degrees, okay, is the same as 4 cos 5 on 4 pi, because 225 degrees is 5 on 4 pi. Why? Because if we look at whether it be a unit circle or just any old circle, if we start where we know 0 is, we know that basically 225 degrees, going anti-clockwise from where 0 normally is, would be 180 up to there, and then another 45, and that would get you there. So 180 plus 45 makes 225. So in terms of radians, that's pi radians plus pi on 4 radians, and that equals, well, there, if you need to put them both over 4, I suppose I could just say it's 5 pi on 4, but just in case you're not sure, it's 4 pi plus 1 pi over 4. 4 pi and 1 pi make 5 lots of pi. Okay, and it's 5 pi on 4. So they're equivalent. So anytime you see something that's got a pi in it, like y equals 3 sine 3 pi on 4 x, that is an indication that we are in radians, and radians are the more useful for modeling trig functions.